Hello everyone, Dennis here. In this video, I'm going to discuss with you GCE O-Level Additional Mathematics October-November 2023 paper 2. The subject code is 4049. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Also, don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. The coefficient of x cubed in expansion of k plus 2x times with 2 minus half x to the power of 6 is 0. Find the value of the constant k. 5 marks. So here's the solution. Given this expression, we can expand the bracket with the power of 6 with the binomial theorem formula, and this is what we get. K plus 2x times with 2 to the power of 6 plus 6 choose 1 times 2 to the power of 5 times negative half x plus 6 choose 2 times 2 to the power of 4 times negative half x square plus 6 choose 3 times 2 cube times negative half x to the power of 3 plus ... Okay, so we don't have to expand everything. We just need to expand the first 3 terms because we just need to find the coefficients of x cubed. So to get x cubed term, this constant k multiply with this term to get x cubed term. So which we get k times 20 because 6 choose 3 is 20 times 8 because 2 cube is 8, then times negative 1 by 8 because negative half cube is negative 1 by 8, then x cubed, followed by 2x times with the second term in the second bracket, and we'll get 2 times 15 times 16 times 1 over 4 times x cubed. Then we calculate the constant. Over here, we'll get negative 20 kx cubed plus 120 x cubed. We can factorize x cubed. We'll get 120 minus 20k x cubed. So since it is given that the coefficient of x cubed equal to 0, therefore 120 minus 20k equals 0, which means k equals to 120 over 20, which is 6. Question 2. Given this diagram, the diagram shows a circle center C with FD as diameter. The tangent at point B on the circle meets DF extended at point A. Point E lies on AB extended, and X is the point of intersection of BD with EC. A. Prove that triangle ABD is similar to triangle AFB. 4 marks. So here's the solution. Let's identify the two triangles that we want to prove. So this is the triangle ABD, and this is the triangle ABF. So we first look at angle BAF, which is this angle. It is a common angle for both triangles. Next, we look at angle ABD, which is this angle. It is equal to angle BDA, which is this angle, because alternate segment theorem. So we have proven that these two triangles have two pairs of angles that are equal. Therefore, by AA similarity test, triangle ABD is similar to triangle AFB. A circle can be drawn through B, C, and X with BC as diameter. So let's connect point B and point C with a straight line. So this line BC is a diameter of a circle that passes through point B, C, and X. B. What type of quadrilateral is EBFC? Give reasons to support the answer. 5 marks. So here's the solution. This is the quadrilateral that we are interested in, quadrilateral EBFC. So first, we can say that angle BXC equals to angle FBD, which is 90 degrees. So this is the angle BXC and this is the angle FBD. They are 90 degrees because they are the right angles in a semicircle. Next, we look at the angle XCB, which is this angle. It is added with 90 degrees and angle XBC gives us 180 degrees. The reason is because it is the sum of interior angle of triangle BXC. Then we can calculate the angle XCB, which is equals to 180 degrees minus 90 degrees minus angle XBC, and calculate the angles there. We get 90 degrees minus angle XBC. Next, we look at the angle CBF plus angle XBC equals to 90 degrees because these two angles make angle FBD, which is 90 degrees. Hence, angle CBF equals to 90 degrees minus angle XBC, and this angle equals to angle XCB, which means that by alternate angles, BF is parallel with EC. Therefore, we can say that EBFC is a trapezium. Question 3. Tea is poured into an empty cup. The temperature Tc degrees Celsius of the tea in the cup T minutes after it is poured is modeled by the formula Tc equals 86 e to the power of negative 0.06 T. A. State the initial temperature of the tea, 1 mark. To find the initial temperature of the tea, we let T equals 0. Hence, the equation becomes Tc equals 86 e to the power of negative 0.06 times 0, which is 0, and calculate the value, we get 86 degrees Celsius. B. Find the time taken for the temperature of the tea to drop to 37 degrees Celsius, 3 marks. So, when Tc equals 37 degrees Celsius, the equation becomes 37 equals 86 e to the power of negative 0.06 T. Then we solve this equation, making e to the power of negative 0.06 T the subject. It is equals to 37 over 86. Then negative 0.06 T is ln 37 over 86. And T is negative 1 over 0.06 times ln 37 over 86. Then we calculate the values, we get 14.1 minutes in 3 significant figures. C. Some tea is poured into an empty cup and at the same time, the same volume of tea is poured into an empty flask. The temperature TF degrees Celsius of the tea in a flask at time t minutes after it is poured into the flask is modeled by TF equals 86 e to the power of negative lambda t, where lambda is a constant. The formula Tc still applies. 1. After 1 hour, the temperature of the tea in a flask is 82 degrees Celsius. Find lambda, 2 marks. So to find the value of lambda, given that the formula Tf equals 86 e to the power of negative lambda t, when the time is 1 hour or 60 minutes, the temperature Tf is 82 degrees Celsius. So we substitute these values into the equation. We get 82 equals 86 e to the power of negative 60 lambda. Then we solve this equation. E to the power of negative 60 lambda equals 82 over 86. Negative 60 lambda is ln 82 over 86. And lambda is negative 1 over 60 ln 82 over 86. Then we calculate the value of lambda. We get 0.000794 to the nearest 3 significant figures. Two. Use your answer from part C1. Find the time when the temperature of the tea in the cup is half the temperature of the tea in a flask. 3 marks. So to solve this question, given that the temperature of the tea in a cup is half the temperature of the tea in a flask, then we can form the equation Tc equals half Tf. Then we substitute the formula of Tc and Tf into this equation. We will get 86 e to the power of negative 0.06 t equals half times 86 e to the power of negative 0.000794 t. The next thing we need to do is we solve this equation to get the value of t. First, cancel out the 86 for both sides. Then the equation becomes e to the power of negative 0.06 t equals half e to the power of negative 0.000794 t. So if further solving this equation, we will have e to the power of negative 0.06 t over e to the power of negative 0.000794 t equals half. Applying the indices law, we get e to the power of negative 0.0592 t equals half. So if further solving this equation, negative 0.0592 t equals ln half. T will be negative 1 over 0.0594 ln half. Then we calculate the value of t, we get 11.7 minutes. Question 4. Do not use calculator in this question. A. Use the identity for tangent 2a to show that tangent 15 degrees equals 2 minus sub 3, 5 marks. So here's the solution. The identity for tangent 2a is tangent 2a equals 2 tangent a over 1 minus tangent square a. So as you can see from this equation, the angle at the left hand side is twice the angle at the right hand side. So 2a at the left hand side, at the right hand side is a and a. So we can start with tangent 30 degrees equals 2 tangent 15 degrees over 1 minus tangent square 15 degrees. Alright, so why I want to do this? Because the tangent 30 degrees, recall that it is a special angle. So tangent 30 degrees is 1 over sub 3, tangent 45 degrees is 1, tangent 60 degrees is sub 3. So we can substitute this tangent 30 degrees, it becomes 1 over sub 3. Then everything for the right hand side, we just copy down. 2 tangent 15 degrees over 1 minus tangent square degrees. Tangent square 15 degrees. Next, for this part, we can rationalize. We get sub 3 over 3 equals 2 tangent 15 degrees over 1 minus tangent square 15 degrees. Then we cross multiply. We have sub 3 times 1 minus tangent square 15 degrees equals 6 tangent 15 degrees. Next, we expand the bracket. We have sub 3 minus sub 3 tangent 15 degrees. Tangent square 15 degrees equals 6 tangent 15 degrees. So this is a quadratic equation if you notice quite carefully. So we will make the left hand side to be 0, then equals 2. So everything for the left side move to the right hand side. I will get sub 3 tangent square 15 degrees plus 5 tangent 15 degrees minus sub 3. So let x to be the tangent 15 degrees, so it will become 0 equals sub 3 x square plus 6x minus sub 3. Alright, so where the a is sub 3, b is 6, and c is negative sub 3. Then we solve this quadratic equation using the formula method, where x equals negative b plus minus square of b squared minus 4ac over 2a. So for this case, the x is tangent 15 degrees, so negative b, the b is 6, plus minus square root of b squared, so it's 6 squared minus 4a sub 3, and the c is negative sub 3, over 2a, which is 2 sub 3. Alright, so after that, we simplify the number inside the sub here. We have negative 6 plus minus sub 48 over 2 sub 3. Okay, so now from here, we know that 15 degrees is in the first quadrant, so this is tangent 15 degrees. So tangent 15 degrees in the first quadrant, it is positive as well. Hence, we can ignore the negative sign here. It becomes negative 6 plus sub 16 times 3 over 2 sub 3. Alright, so why we want to do this? Because we can square root 16 and we get negative 6 plus 4 times sub3 over 2 sub3. Okay, now one thing, a very common mistake that made by the student is they will cancel the sub3. Okay, so for this case, we can just cancel the sub3 because at the top here, the numerator, we have two terms, negative 6 plus 4 sub3, so we can just cancel. So what we can do is, the first thing is we can get rid of the 2 here by dividing 2 for the numerator and the denominator. We get negative 3 plus 2 sub3 over sub3. And I want to get rid of the sub3 at the denominator. I can rationalize where I multiply sub3 for both numerator and denominator. I'll get 2 times 3 minus 3 sub3. Okay, because negative 3 times sub3, I get minus 3 sub3. 2 times sub3 times sub3, it becomes 2 times 3. So the denominator sub3 times sub3, I'll get 3. Then from here, we can factorize the 3. We get 3 bracket 2 minus sub3 over 3. Cancel out the 3. So tangent 15 degrees will be equals to 2 minus sub3. Hence shown. B. Prove that tangent 15 degrees minus tangent 105 degrees equals 4. 5 marks. So to prove this identity, we can start from the left-hand side. So from the left-hand side, it is equals to tangent 15 degrees minus tangent 105 degrees, which is tangent 15 degrees minus tangent bracket 60 degrees plus 45 degrees. Recall that the addition formula, tangent A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. So this equation becomes tangent 15 degrees minus bracket tangent 60 degrees plus tangent 45 degrees over 1 minus tangent 60 degrees tangent 45 degrees. So as we know that tangent 60 degrees is sub3, tangent 45 degrees is 1. Hence, this equation becomes 2 minus sub3, where tangent 15 degrees we've got it from the previous question. Then minus sub3 plus 1 over 1 minus sub3 times 1. So simplify the bracket, we have 2 minus sub3 minus bracket sub3 plus 1 over 1 minus sub3. Then we can start to rationalize the fraction in the bracket where we multiply it with 1 plus sub3 over 1 plus sub3, which will get 2 minus sub3 minus bracket 3 plus 2 sub3 plus 1 over 1 minus 3. And we get 2 minus sub3 minus bracket 4 plus 2 sub3 over negative 2. So from here, we can divide the both numerator and denominator by negative 2. We'll get negative 2 here, and for this case is negative 1. So the equation becomes 2 minus sub3 minus bracket negative 2 minus sub3. And the answer is 4, hence shown. Question 5. When y equals 3 cosine 3x minus 5 sine 3x, the expression p times d squared y over dx squared plus q times dy over dx plus 14y plus 34 sine 3x may be written in the form a cosine 3x plus b sine 3x, where p, q, a, and b are constants. A. Show that a equals 42 minus 27p minus 15q, and find b in terms of p and q. 7 marks. So here's the solution for this question. Given the equation y equals 3 cosine 3x minus 5 sine 3x, we can differentiate this equation. We get dy of dx equals negative 3 sine 3x times 3 minus 5 cosine 3x times 3. Then simplify, we will have negative 9 sine 3x minus 15 cosine 3x. Next, we find the second derivative, where d squared y over dx squared equals negative 9 cosine 3x times 3 plus 15 sine 3x times 3. Then multiply the constants. We have negative 27 cosine 3x plus 45 sine 3x. Next, given the expression p d squared y over dx squared plus q dy over dx plus 14y plus 34 sine 3x, we substitute d squared y over dx squared, where p equals where it becomes p times negative 27 cosine 3x plus 45 sine 3x. Then next we substitute dy over dx, it becomes plus q times negative 9 sine 3x minus 15 cosine 3x. And also the y, so we will have 14 times 3 cosine 3x minus 5 sine 3x. And lastly, copy the last term, plus 34 sine 3x. The next thing we do is we extend the bracket. We have negative 27p cosine 3x plus 45p sine 3x minus 9q sine 3x minus 15q cosine 3x plus 42 cosine 3x minus 70 sine 3x. And the last term is plus 34 sine 3x. So once we reach this step, we want to combine the like terms. So let's identify the like terms first. So these three terms are the like terms. When we combine them together, we'll get negative 27p minus 15q plus 42 times cosine 3x. Next, the remaining terms here, they are also like terms. So when we combine them together, it becomes 45p minus 9q minus 70 plus 34 sine 3x. So we will calculate or combine the constants. Then we will have negative 27p minus 15q plus 42 times cosine 3x plus 45p minus 9q minus 36 times sine 3x. So once we reach here, we can identify the A and the B, where we compare this expression with this expression. So in front of cosine 3x is A. So that means this will be the A. Hence, A equals 42 minus 27p minus 15q. So this is the equation that we need to prove, hence shown. So next one what we want to do is to find the B. So now we compare again. This is B. Before sine 3x, it is the B here. Alright, so therefore B will be 45p minus 9q minus 36. B. In the case where A and B are both 0, find the values of P and Q. 3 marks. So for this question, we want to find two unknowns. Therefore, we need to form two equations and solve simultaneous equations to find the values of P and Q. We start with the equation of A equals 42 minus 27P minus 15Q. Since A is 0, then the equation becomes 0 equals 42 minus 27P minus 15Q. So we rearrange this equation so that we can do simultaneous equation easier later. So it becomes 27p plus 15q equals 42. Next, we divide 3 for both sides. We'll have 9p plus 50 plus 5q equals 14. So this will be our first equation. Next, we also know b equals 45p minus 9q minus 36. So when b is 0, then the equation becomes 0 equals 45p minus 9q minus 36. So we do the similar thing for the equation number 1. So for this case, 45p minus 9q equals 36. Then we divide by 3 for both sides. We'll get 5p minus q equals 4. Hence, q equals 5p minus 4. I will label this as equation number 2. Then I use substitution method to solve this simultaneous equation. Substitute equation number 2 into equation number 1. Hence, 9p plus 5 times 5p minus 4 equals 14. Expand the bracket, we have 9p plus 25p minus 20 equals 14. Then we solve this equation, 34p equals 34, therefore p equals to 1. So we already know p equals to 1, then we can find the value of q, where q equals 5 times 1 minus 4, and the q value is also 1. So this is the answer for part B. Question 6. A. Show that 2x plus 1 is a factor of 6x cubed minus 7x squared minus x plus 2, and hence factorize 6x cubed minus 7x squared minus x plus 2 completely. 5 marks. So here is the solution. We will let 2x plus 1 equals to 0, hence x equals negative half. We also represent the expression given in function form. Then we will let fx equals 6x cubed minus 7x squared minus x plus 2. Next, we substitute x equals to negative half into this function. Therefore, f negative half equals 6 times negative 1 over 2 cubed minus 7 times negative half square minus negative half plus 2. So we calculate. Here we get f negative half equals to 0. By factor theorem, 2x plus 1 is a factor, hence shown. So the next thing we need to do is we want to factorize 6x cubed minus 7x squared minus x plus 2. So to do this, we have two methods. The method number 1 is the synthetic method. So what we do is we will write all the coefficients of the given expression. For this case is 6 minus 7 minus 1 and 2. And since x is negative half, so we write the negative half at the left hand side. Next, we copy down the 6. Then negative half times 6 will get negative 3. And negative 7 plus negative 3 will get negative 10. So next thing we do is we repeat a similar process. Negative half times negative 10 will get 5. So negative 1 plus 5 will get 4. Negative half times 4 will get negative 2. 2 plus negative 2 will get 0. So we need to make sure that the last digit here is 0 so that it is confirmed that 2x plus 1 is a factor. So from here we will get 2x plus 1 times 6x squared minus 10x plus 4 equal to 0. We can factorize the 2 in the second bracket, so we get 2 bracket 2x plus 1 times 3x squared minus 5x plus 2 equal to 0. Then we will divide by 2 for both sides. We will get 2x plus 1 times 3x squared minus 5x plus 2 equals to 0. Hence, function fx equals 2x plus 1 times 3x squared minus 5x plus 2. So the next step we do is we can factorize the quadratic factor here, and it becomes 2x plus 1 times 3x minus 2 times x minus 1. So this is method number 1 using synthetic method. If you don't like this method, we can use the second method, which is the long division method. So for long division method, we'll divide it using this approach. So 6x cubed minus 7x squared minus x plus 2. So this is the dividend. It is divided by the divisor 2x plus 1. So 3x squared times 2x plus 1 will get 6x cubed plus 3x squared. So the top minus the bottom will get negative 10x squared. Then I copy down the negative x here and multiply 2x plus 1 with negative 5x. We'll get negative 10x squared minus 5x. Then we minus negative 10x squared minus x with negative 10x squared minus 5x. We'll get 4x. Repeat the same process, copy down the 2 here, and multiply 2x plus 1 with positive 2. We'll get 4x plus 2. And minus these two expressions, we'll get 0. Hence, fx equals 2x plus 1 times 3x squared minus 5x plus 2. Alright, so the 2x plus 1 is the divisor, 3x squared minus 5x plus 2 is the quotient. Then we factorize 3x squared minus 5x plus 2. We'll get 2x plus 1 times 3x minus 2 times x minus 1. So this is method number 2 to solve this question. B. Solve the equation 6 times 4 to the power of y plus 2 times 2 to the power of negative y equals 7 times 2 to the power of y plus 1, 5 marks. So here's the solution. Given this equation, we can apply the indices law and it becomes 6 times 2 to the power of y squared plus 2 over 2 to the power of y equals 7 times 2 to the power of y plus 1. So to make our calculation easier, we substitute x equals 2 to the power of y. Hence, the equation becomes 6x squared plus 2 over x plus 7x. 6x squared plus 2 over y equals 7x plus 1. Then we multiply x for both sides to get rid of the fraction. Then we will have 6x cubed plus 2 equals 7x squared plus x. After that, we move everything to the left hand side. We will have 6x cubed minus 7x squared minus x plus 2 equal to 0. So this cubic equation, we know that it can be factorized into this manner from part A. So it becomes 2x plus 1 times 3x minus 2 times x minus 1 equals to 0. Hence, 2x plus 1 equal to 0 or 3x minus 2 equal to 0 or x minus 1 equal to 0. Therefore, x is negative half or x is 2 over 3 or x equals to 1. But don't just stop here because we want to find the value of y. So x is 2 to the power of y. Hence, it is equals to negative half or 2/3 or 1. So for the first answer, there is no solution because 2 is a positive value. To the power of something, we won't get a negative number. Hence, there is no solution. For the second roots, we can solve it by using logarithm. So y equals log 2, 2 over 3. For the third root, y equal to 0. Then for the logarithm here, we can change the base so that we can press calculator and calculate. So we have log 10, 2 over 3 over log 10, 2. And the value of y will be negative 0.585 to the nearest 3 significant figures. So this is the answer for question 6. C. Show that the negative solution from part B may be written in the form 1 minus log AB, where A and B are integers to be determined. 2 marks. So here's the solution. From 2 to the power y equals 2/3, where y is log 2 over 3. And applying the logarithm laws, we get log 2, 2 minus log 2, 3. So log 2, 2 is 1, and then it becomes 1 minus log 2, 3, where A equals to 2 and B equals to 3. Hence, this is the answer for part C. Question 7. A. The graph of y equals A cosine bx has one maximum point at 7 pi over 2, 10, and the next maximum point after this has coordinates 9 pi over 2, 10. Find the values of the constants A and B. 2 marks. So here's the solution. Before we want to get the values of A and B, it is good to have a sketch of the equation y equals A cosine bx. So it is the cosine graph and it will look like this. Given that the maximum point is 7 pi over 2 and 10, and the next maximum point is 9 pi over 2, 10. So in order to find the value of A, it is the amplitude of the waveform. Therefore, A equals to 10. To get the period t. This is 7 pi over 2 and this is 9 pi over 2. So this is the period. Therefore, we'll get 9 pi over 2 minus 7 pi over 2, which will get pi. B is 2 pi over t. Then it is equals to 2 pi over pi, which is 2. B. A particle travels in a straight line has velocity v meters per second at time t second where t is greater or equal to 0 given by the equation v equals 5 sine 0.2 t plus c where c is a positive constant. 1. Find the smallest value of c in order that the particle will never change its direction. 3 marks. So here is the solution. Given by the equation of the velocity v equals 5 sine 0.2 t plus c. Since the particle travels in a straight line, there is no change in direction. Therefore, the v must be greater or equals to 0. And since 5 sine 0.2 t will be between negative 5 to 5 inclusive, as this is a sine function, then we can plus c for all the sides here. The inequality becomes negative 5 plus c less than or equals to 5 sine 0.2 t plus c less than or equals to 5 plus c. Okay, so since the v is 5 sine 0.2 t plus c, then the inequality will be negative 5 plus c less than or equals to v less than or equals to 5 plus c. Since we know that v is greater or equal to 0, therefore negative 5 plus c is greater or equal to 0, and c will be greater or equal to 0. So from this inequality, we can see that the minimum value of c will be equals to 5. Question 8. Given this diagram, the diagram shows a symmetrical wooden framework ABCDEA consisting of 7 pieces of wood. AED is a straight line. The section AB, BE, EC, and CD are each length of r cm where r is a constant. Angle BAE equals theta for a range from 0 degree to 90 degrees. A. Expressed the area enclosed by the framework in terms of r and sine 2 theta. 3 marks. So here's the solution. From the diagram, we can see that the framework is made out of 3 identical triangles. So what we have to do is we just need to find the area of one triangle, then we multiply by 3 to get the area of the framework. So we look at the triangle ABE and especially this angle. So this angle ABE is 180 degrees minus 2 theta. Alright, so as you can see, triangle ABE is an isosceles triangle. So the area of triangle ABE will be half r squared sine 180 degrees minus 2 theta. Alright, so this is the formula to find the area of a triangle. Then sine 180 degrees minus 2 theta is sine 2 theta. So the equation becomes half r squared sine 2 theta. Hence, the area of the framework will be 3 times of the area of triangle ABE, which will get 3 times half r squared sine 2 theta, and we simplify to get 3 over 2 r squared sine 2 theta. Question B. Given that theta can vary, find in terms of r the maximum possible area enclosed by the framework and the value of theta at which this occurs. You are not required to justify this area is a maximum. 2 marks. Here is the solution. As we can see, the equation of the area of framework 3 over 2 r squared sine 2 theta, and r is a constant. The function sine 2 theta has a value in a range from -1 to 1 inclusive. So if you don't remember or not very sure why is the reason, just look at the sine 2 theta graph. Alright, so the maximum value is 1 and the minimum value is -1. So in order to get the maximum area, the sine theta will be equals to 1. Hence, the maximum area will be 3 by 2 r squared. And sine 2 theta need to be equals 1. Then we solve this equation to get the value of the theta. So 2 theta will be 90 degrees and theta will be 45 degrees. A similar framework is made from a single piece of wood of length 8r sine theta meters. There is no wood wasted. C. Show that for sine theta minus 3 cosine theta equals 2. 2 marks. Here is a solution. First, we apply sine rule and get this equation. AE over sine 180 degrees minus 2 theta equals r over sine theta. Then we make AE the subject. It becomes r sine 2 theta over sine theta. Remember, from the previous question, we know that sine 180 degrees minus 2 theta is sine 2 theta. That's how we get AE is r sine 2 theta over sine theta. Next, given that the total length to make up this framework is 8r sine theta. So from the diagram here, the total wood length, which we add all the sides here together, will get 4r plus 3 times of AE, which is r sine 2 theta over sine theta. Alright, so here 1, 2, 3, 4. We have 4 R's and 3 AEs. So this is for first AE, BC is same as AE, so second AE, ED is also same as AE. Okay, because all these three triangles are congruent. Alright, then from here, the sine 2 theta, we apply double angle formula. Sine 2 theta is 2 sine theta cosine theta, and we'll get this equation for r plus 3r times 2 sine theta cosine theta over sine theta equals 8r sine theta. The next step we can do is we can cancel out the sine theta and also the r for both sides. We divide r for both sides and simplify the equation. We have 4 plus 6 cosine theta equals 8 sine theta. So once we reach this step, we can rearrange this equation so that it will be the equation that we want, where 8 sine theta minus 6 cosine theta equals to 4. Then we divide by 2 for both sides. We will get 4 sine theta minus 3 cosine theta equals 2, which is same as this equation, hence shown. D. By expressing 4 sine theta minus 3 cosine theta in the form r sine theta minus alpha, where r is greater than 0 and alpha is between 0 degrees to 90 degrees, find the value of theta. 5 marks. So from part C, the equation that we get is 4 sine theta minus 3 cosine theta equals 2. So we have to apply the r formula so that this equation will be in the form of r sine theta minus alpha. So the first thing we need to do is we need to find the r value, so which is square root of 4 square plus 3 square, and the r value will be 5. Then we want to find the alpha value, which is inverse of tangent 3 over 4, and alpha value is 36.9 degrees. Now we can rewrite the equation in the r formula form, which is 5 sine bracket theta minus 36.9 degrees equals to 2. Then we just need to solve this equation to find the value of theta. So sine theta minus 36.9 degrees equals 2 by 5. Theta minus 36.9 degrees is inverse of sine 2 by 5. Theta will be 23.6 degrees plus 36.9 degrees, which is 60.5 degrees. Question 9. Given this diagram, The diagram shows rough level ground in the shaded region bordered by a straight level road BXA. Point C is on the rough ground and B is the point on the road closest to C. The distance AB is 15 kilometers and BC is 8 kilometers. A cross-country runner is at point A on the road and needs to get to point C as quickly as possible. The runner can maintain a speed of 5 km per hour on the road, but only 3 km per hour over the rough ground. The runner realizes that in order to minimize the total time to get to C, it is necessary to leave the road at some point X between A and B and then run directly from X to C. Let Ax be X kilometers and T be the total time in hours taken by the runner to get from A to X and then from X to C. A. Show that the time T equals x over 5 plus square root of x squared minus 30x plus 289 over 3. 3 marks. So here's the solution. From the diagram, we can see that bx equals to 15 minus x. Then by applying Pythagoras theorem, cx equals square root of 15 minus x squared plus a squared. Expand the bracket, we will get square root of 225 minus 30x plus x squared plus 64. Simplify, cx equals square root of x squared minus 30x plus 289. We know that time equals distance divided by the speed. So the total time will be the time traveled from A to X and the time travels from X to C. Hence Tax plus Txc. So Tx will be x over 5, Txc will be square root of x squared minus 30x plus 289 over 3. Hence T equals x over 5 plus square root of x squared minus 30x plus 289 over 3 shown. B. Find an expression dt over dx and hence show that the value of x for which the time taken is a minimum satisfies the equation x squared minus 30x plus 189 equals 0. 6 marks. So for this question, there are two things we need to do. The first thing is we want to find dt over dx. So from the previous question, we can write the equation of the time t in indices form so that we can differentiate easily. So the t equals x over 5 plus 1/3 bracket x squared minus 30x plus 289 to the power of half. Then we can start to differentiate dt over dx. It will be equals to 1 over 5 plus 1 over 6 bracket x squared minus 30x plus 289 close bracket to the power of negative half times with 2x minus 30. Then we rearrange this equation. dt over dx equals 1 over 5 plus 2 bracket x minus 15 over 6 square root of x squared minus 30x plus 289. Then simplify 2 and 6, we get dt over dx equals 1 over 5 equals x minus 15 over 3 square root of x squared minus 30x plus 289. So the next thing we need to do is we want to prove the equation x squared minus 30x plus 189 equals to 0. So given that the minimum point, then dt over dx will be equals to 0. Therefore, 0 equals 1 over 5 plus x minus 15 over 3 square root of x squared minus 30x plus 289. So we have to rearrange this equation so that it becomes the equation that we want to prove. So what we can do is we multiply 15 for both sides. Then the equation becomes 0 equals 3 plus 5 bracket x minus 15 over square root of x squared minus 30x plus 289. So rearrange the equation. 3 equals 5 bracket 15 minus x over square root of x squared minus 30x plus 289. So you're not really sure what I'm doing here. So I just move this term to another side. It should be negative the whole thing. But I switch x minus 15 to 15 minus x, then I don't have to put a negative sign in front. Okay, so the next thing I do is I will bring this to the left hand side. It becomes multiply. So 3 square root of x squared minus 30x plus 289 equals 5 bracket 15 minus x. Next, I will square both sides so that I can get rid of the square root. It becomes 9 bracket x squared minus 30x plus 289 equals, so 5 squared is 25. 50 minus x squared, expand the bracket, I will get 225 minus 30x plus x squared. Next, expand the bracket, we'll get 9x squared minus 270x plus 2601 equals 25x squared minus 750x plus 5625. Okay, so rearrange this equation so that the coefficient x squared is positive. Then I have to move everything to the right hand side, and it becomes 0 equals 16x squared minus 480x plus 3024. Alright, so when I look at this, I know that all these numbers is divisible by 16. Then becomes 0 equals x squared minus 30x plus 189. So this equation is same as this equation, hence shown. C. Hence, find the minimum time taken in hours and minutes for the runner to get from A to C. You are not required to justify that this time is a minimum. 3 marks. So here's the solution. Before we want to find the minimum time taken, first we have to solve this equation, which we get from part B. 0 equals x squared minus 30x plus 189, because this is the equation when the time is minimum. So we can factorize the quadratic equation. It becomes 0 equals bracket x minus 9 times bracket x minus 21. Hence, x equals to 9 or x equals to 21. However, we need to reject x equals to 21 because x is less than 15 based on the diagram. Now we can calculate the t value or the total time taken, which is x over 5 plus square root of x squared minus 30x plus 289 over 3. Substitute the x equals to 9. We get 9 over 5 plus square root of 9 squared minus 30 times 9 plus 289 over 3. And we'll get 5 and 2 over 15 hours. Then we convert it to hours and minutes, which is 5 hours and 8 minutes. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.